Hello everyone and welcome to today's session. We will be talking about an essential statistical tool, the paired samples t-test. We'll walk through the concept, assumptions, and step-by-step process using real-world examples to make it practical and relatable. By the end, you'll know exactly when and how to apply it. Let's get started. The paired sample t-test compares the mean of two measurements taken from the same individual, object, or related units. These paired measurements can represent things like a measurement taken at two different times, example, pre-test and post-test scores with an intervention administered between the two time points. A measurement taken under two different conditions, example, completing a test under a control condition and an experimental condition. The purpose of the test is to determine whether there is a statistical evidence that the mean difference between paired observations is significantly different from zero. The variables used in this test is known as dependent variable or test variable, which has to be a continuous variable measured at two different times or for two related conditions or units. Your data must meet the following requirements. First, dependent variable that is continuous. That is, it should have been measured at interval or ratio level. Note, the paired measurements must be recorded in two separate variables. Related samples groups, that is dependent observations, the subjects in each sample or group are the same. This means that the subjects in the first group are also in the second group. Random sample of data from the population. Normal distribution, approximately, of the difference between the paired values. No outliers in the difference between the two related groups. Also, please note, when testing assumptions related to normality and outliers, you must use a variable that represents the difference between the paired values, not the original values themselves. The hypothesis for the test can be expressed in two different ways that express the same idea and are mathematically equivalent. If mu1 is the population mean of variable 1 and mu2 is the population mean of variable 2, then the null and alternate hypothesis can be written as H0, where mu1 is equal to mu2. The paired population means are equal. The alternate hypothesis H1, where mu1 is not equal to mu2. The paired population means are not equal. The same thing can also be written as H0, mu1 minus mu2 is equal to 0. The difference between the paired population mean is equal to 0. H1, mu1 minus mu2 is not equal to 0. The difference between the paired population mean is not 0. The test statistics can be represented as what you see in front of you on the slide. A word of caution when using the paired samples t-test. It can only compare the means for two and only two related paired units on a continuous outcome that is normally distributed. The paired sample t-test is not appropriate for analysis involving the following. 1. Unpaired data. 2. Comparisons between more than two units or groups. 3. A continuous outcome that is not normally distributed. 4. An ordinal or ranked outcome. Let's take a dipstick on your understanding of the topic so far. What is the primary purpose of a paired sample t-test? The options are as following. A. To compare the means of two unrelated groups. B. To test whether the mean difference between two unrelated observations is significantly different from 0. C. To analyze the variance between two independent samples. And D. To evaluate the relationship between two categorical variables. Well, you can pause the video, maybe refer to your notes and then answer. The correct answer is B, to test whether the mean difference between two related observations is significantly different from 0. Now let's understand how a paired sample t-test can be run using SPSS. Before that, consider the following scenario. Evaluating employee training effectiveness at Swift Solutions. Swift Solutions is a mid-sized tech support company. It is focused on enhancing the skills of its employees to improve customer satisfaction. Recently, the management implemented a new training program aimed at boosting problem-solving efficiency and reducing customer query resolution time. Now they want to assess whether this program has genuinely improved employee performance. To do this, the HR team has designed a simple study. Before the training, all employees took a standardized problem-solving test tailored to measure their efficiency in resolving a technical query. After completing the 2-week training program, the employees took the same test again. This second round of scores represents their post-training performance. The company wants to determine if the training made an impact on the performance of the employees. Let us now run this test in SPSS and try and interpret the results. So the data that the HR department collected has been stored in this SPSS file. Looking at the variable view, we can see we have got 4 variables here: candidate ID, we have gender, we have pre-training performance scores, and we also have post-training performance scores. Pre-training and post-training performance scores have been measured at the scale level. Let's also quickly have a look at what our data looks like. In order to apply the paired sample t-test, we will go to the Analyze menu, Compare Means, and then from here we will select Paired Sample t-test. Now we have got pre-training performance and post-training performance. Let us transfer post-training performance under variable 1. Let us also transfer pre-training performance under variable 2. Let's click in Options and maintain 95% as the confidence interval percentage. Let's click on Continue and then we click on OK. This is the output that we get in SPSS. The first table is giving you the mean, the sample size, the standard deviation, and standard error. The second is telling you about the correlations. As we can see, the correlation is a high positive correlation between, that is 0.868, which is also significant at p-value of 0.000. The third table is giving us the paired sample test output. Now, if we look at the p-value here, again we find that it is significant. The two-tailed significant value is 0.000, which means that there is a significant difference in performance after the training was given to the employees. If we go back and refer to the first table, we have the post-training performance mean as 72.73, whereas the pre-training performance score mean is 63.57. Hence, we can conclude that the training had a significant positive impact on the performance of the employees, which increased after the training was given. This is how we can interpret the results of the paired sample t-test. So the results of the test can be reported as pre and post performance of the employees was found to be strongly positively correlated, where R was found to be 0.868 and p-value was found to be less than 0.05. There was a significant difference between pre and post performance of the employees, where again the p-value was found to be less than 0.05. So in this video, we learned what is a paired comparison t-test, its assumptions, hypothesis, and how to run and interpret the result using SPSS. That's all for now. See you in the next video. Thank you.